Hi, this is Ms. Moser, and this is a brief tutorial to acquaint you with chemical reactions and chemical equations. Just an introduction. We'll start off by asking this question. What is a chemical reaction? There's a fairly simple answer. A chemical reaction is the process by which one or more substances are changed into one or more different substances. So in other words, we come out of a chemical reaction with different stuff than we started with. But there are a few important things to note. The reactants are what go into the reaction, and the products are what emerge once the reaction is complete. The big important thing to know is that the mass of the reactants must be equal to the mass of the products. There's just no way around this. It's the conservation of mass. We can't create or destroy matter, so the mass of the reactants must always equal the mass of the products. To summarize that on a slide, a chemical reaction is the process by which one or more substances are changed into one or more different substances. The reactants are your original substances, and the products are what result from the reaction, and the total mass of reactants and products must be equal. Okay, so now let's talk about how you might know that a chemical reaction has occurred. You know that a chemical reaction has occurred when a few different things happen. The first obvious hint is that there's a release of heat or light. We have here a wooden splint burning with some wax. Both the wax and the wooden splint are undergoing a chemical change and becoming some new substance. And we can tell that because they're releasing both heat and light. Another simple way to tell is if a gas is produced. That means bubbles. And we have here a favorite of home chemists everywhere. When we mix them, what will happen? An insoluble gas will be produced, meaning that the substance will appear to bubble. Another way to tell that a chemical reaction has occurred is when a precipitate is formed. So a precipitate is formed when a formerly clear substance undergoes a change, and you add something to it, and suddenly the substance appears cloudy or milky. That is the formation of a precipitate. Here we have this formerly beautiful crystal blue substance that, with the addition of a sugar and some heat, has turned this really weird cloudy green. That leads us to the fourth indication that a chemical reaction has occurred, and that's color change. This is bromothymol blue, and it's a wonderful indicator substance that can tell us when a solution is acid. It's currently sitting in some nice neutral water, but if I add a little bit of plain household vinegar to it, the following magical transformation will occur. Pretty neat, huh? The color change occurs because a chemical reaction has taken place and new compounds have been formed which have a different color. So there are your four indications of a chemical reaction having taken place. Release of heat or light, production of a gas, that means bubbles, formation of a precipitate when a formerly clear solution suddenly goes cloudy, and or a color change. Obviously, some situations will involve more than one of these occurring, but those four give you a pretty good idea that a chemical reaction has occurred. The next question we want to ask is, what's a chemical equation? So we've covered what a chemical reaction is, one or more substances being transformed into one or more different substances, but how is that different than a chemical equation? The chemical equation describes the chemical reaction. They are not the same thing, one merely describes the other. So again, a chemical equation describes the reaction that's occurred, and it represents with symbols and formulas the identities, states, and relative amounts of both the reactants, that's the stuff that went into the reaction, and the products, the stuff that resulted from the reaction. So the chemical equation here shows solid ammonium dichromate reacting to form gaseous nitrogen, solid chromium 3 oxide, and some gaseous water. There's a lot of information in there. Any chemical equation has to do three things. It has to represent known facts. It has to have correct formulas for all reactants and products, and it has to satisfy the law of conservation of mass. That's the piece that says the mass of the products and the mass of the reactants have to be equal. We cannot make or destroy mass in the context of an ordinary chemical reaction. That'll be it for now, and we'll talk a little bit more about chemical equations, about writing them and balancing them in our next video, Introduction to Chemical Equations. Have a good night.